Hello everyone, I'm going to make here a video to show how the phase lock loop works, and just for you to see the precision it can get and how I'm doing all of this. First of all, I'm using my frequency generator. Okay, it's now 5000 hertz, and this is using the AD9833 chip, and the output is going to the feedback input of the phase lock loop chip. Okay, so it's going to output phase lock loop, a phase signal into this output that's going to external trigger of the oscilloscope, because I only have 2 channels. So by doing this I can actually have a kind of third channel. So in the first channel you see this is the signal coming from the signal generator. Okay, so that's not the phased signal. Okay, and in this line is the voltage of the voltage controlled oscillator, VCO. Okay, so now I'm on manual tuning, and you can see the kind of precision you can get of the frequency. I was able to tune to the exact same frequency of that with the manual tuning, and as I just touched the knob, you can see that you can kind of dephase it, and as you change the frequency just a little bit, it loses the lock. Actually, it's not. It's locking by parasitic influence of the phase comparator. Okay, but actually it can generate very high precision waveform when it's not locked. Anyway, when I turn on the auto manual switch here, you can see that now it's locked on the other frequency, and I don't know why I'm having these glitches. Well, when I change the offset knob, okay, this 10 turns potentiometer, when I change this, you see the center frequency is changed. So you change the phase of the frequency being generated. As this is the original frequency and the other frequency is coming here in the external trigger, you get the slope coupling by this way. So when you get the trigger, the frequency generated by the phase lock loop is coming right here in the middle. Okay, just like it's right now, kind of zero phase. Okay, this is zero phase. You see the voltage is at minimum, the voltage is at kind of 800 millivolts, less than 1, but it's a kind of out of lock. Okay, so when I just raise it a little off the frequency, you see that it loses completely the lock, and when I lower, you get that it's under the lock. You see it changes the phase but it doesn't change the frequency. Okay, now it's 5002. Let's reduce to 5000 round. Okay, so this is when the voltage on the oscillator is at 2.7 RMS, it's a kind of 180 degrees off from the other wave. Let me show you the other wave. Okay. Okay, let's make the trigger. So the trigger is the channel 2. So as I was telling you, this is a phase lock loop frequency, and this is the original frequency. So it's kind of shaking because it's out of range. Let me put it on the 180 phase, so you can see now it kind of perfectly locks. There's some kind of glitching in my oscilloscope. I don't know what's going on. I need to figure out. But that's it for now. You can see it follows the frequency. Okay, let me change here the frequency. You see? But it loses the phase. It changed the phase. Okay? So it's important to note that the frequency is one thing and the phase is a second thing on the phase lock loop, because it's going to lock within that range, but the phase relationship is going to be tuned by this knob. Okay, you see, you can tune it. That's it for now. Hope you enjoyed. Hope you have a great Sunday. Give a like on the video, please, and comment if you have any questions. See you around.